What about inverse tangent here? So we want to be able to define y equals inverse tangent of x so that tangent y is equal to x. Again, y is an angle. Y is the angle whose tangent is x. Angle whose tan is x. And again, what we're going to do is we're going to restrict our domain, just keep one cycle, so just this primary cycle of the tangent function. This is graph of the tangent function, and it repeats every pi units. So we're just going to keep that one cycle. And if we just keep the one cycle, then it is 1 to 1, right? Horizontal line passes over, hits just one time. So then if we want to see what inverse tangent looks like, then we will need, instead of two vertical asymptotes at pi over 2 and negative pi over 2, we will need horizontal asymptotes at pi over 2 and negative pi over 2. So one right there, that's going to be at pi over 2. And then another one down here at negative pi over 2. About right there. And then we want to reflect that graph over the y equal x line. So let's sketch our y equal x line. So it's going to look like this. 45-degree line. And then our inverse tangent is going to look like this. So it's going to be the reflection here. Like that. So this is y equal inverse tan x. And then this one is y equal tan x, one cycle. So, and this is at y equal negative pi over 2 and y equal pi over 2, horizontal asymptotes. So if we ask, well, what is the limit as x goes to infinity of inverse tan of x? So that's going out to infinity here. You can see inverse tan goes up and it's asymptotic to pi over 2. And then limit of inverse tan as x goes to minus infinity. So you go out to minus infinity, come down to the inverse tan function. It's tapering off to negative pi over 2. So, and again, this is saying the angle whose tangent is x is negative pi over 2, and x is going to minus infinity. So the angle whose tangent is minus infinity, tangent function goes down to minus infinity at negative pi over 2. That's this one. And then this one, the angle whose tangent is infinite, is pi over 2. So here as you approach pi over 2, the tangent goes infinite. So that's the other way to look at it. So, and then we can evaluate a limit here. We want to look at the limit as x approaches 1 from the plus side, 2 over 1 minus x squared. So we want to know, well, what's going on the inside there? So, well, let's do a substitution here. Let's let t, the inside, be 2 over 1 minus x squared. Then I'm looking at the limit, inverse tan of t. And then as t approaches, so as x gets close to 1 from the positive side, what happens to 2 over 1 minus x squared? So x approaches 1 from the positive side is x greater than 1. So that would be x squared. Then this x squared here would also be greater than 1. So then 1 minus x squared, this is bigger than 1, is going to be less than 0. But it's going to be approaching 0 because x squared is approaching 1. So this looks like a number over 0 number over 0 is plus or minus infinity. Top's positive, bottom is negative. This is going to be negative infinity. So actually let me do an arrow here. And that's as x approaches 1 from the plus side. So our t down here is going to minus infinity. So we're really doing limit of inverse tan t, t goes to minus infinity. That's this one here. That's negative pi over 2.